Alright, so I was talking to Brad Martin about his TimeMag project and cam turning in general, and I thought it would be a good idea to do a quick tutorial on how to turn a simple part like his TimeMag. If you haven't checked out his project, it's on Kickstarter. Look up TimeMag. It's a neodymium magnet in a titanium housing. That's pretty cool. Anyway, let's get right to it. Let's start by just making a new part file. First thing you're probably going to do is create a sketch. I think it defaults to the sketch tab. Choose sketch, choose a plane. I pretty much always work on the front plane. Since we're making a turn part, we're going to start by drawing a center line on the x-axis. Don't really care how long this is, doesn't matter much. Then we're going to go to regular line sketching because let's look at it. His TimeMag is, the outside shape of it is mostly made up of straight lines. So we'll just draw something that's pretty similar to what he's got. Something about like that. You'll see that part of it's black, some of the lines are black because they're mostly defined. I started from the origin, which caused a coincident relationship, and my first line was vertical, so it has a vertical relationship, but I didn't tell where that line stopped, so even though the next one's horizontal, it can be moved. So we'll use the smart dimension feature. We'll just start throwing in some dimensions. The first dimension that you throw out as of about Solidworks 2014, it's going to scale the rest of the sketch based on what you put in here. I think he's working with about 3/8 rod, so I'm just guessing that it's probably about 365, which gives you a nice cleanup. Since I sketched this, that'll tell me about how long this is, so I'm just going to again guess that they're about 3/4 of an inch long. Now you can see that that one, when I updated that length, that dimension, it actually shifted that point. I'll do that one more time. I'll go the other direction. You can see it moves that. That's because we're defining this with the dimension rather than in other CAD programs. Usually you draw the geometry to a specific point and then it tells you how far that dimension is. This kind of works the other way. You tell it where you want that point to be. So now you can see that that was blue, it turned black. We'll go through and do the same thing. We'll set these ones with an angle. We'll round that one nice and off. 60 degrees. We'll do the same thing on this one. Let's just call it 145 degrees. Yeah, let's call it 140 degrees. You can see this is still blue because even though the angle is defined, it can still move up and down. Put it back about where it was at because that seems like it's about right. Let's toss out a dimension here. Call that 275. Okay, so now we have our basic our basic sketch. It's fully defined. That's great. Now we'll drop over to the Features tab. We'll use the revolve. This is a turn part, so we're going to use revolved boss/base. It's automatically going to pick up our center line that we drew in there and give you a nice sketch preview. We'll choose OK to continue. Next thing, he's got some grooves on here. We probably want those same grooves. We'll make a new sketch. We're just going to sketch one of those grooves. I'm going to set this so that it's coincident with my outside profile, meaning the center line resides on the outside profile. Go ahead and we'll set up to the front so you can see that. It's on that silhouette edge, it's coincident. I'm going to bet that this is a 1/16 or 0.62.5 is probably about what he's using. Then we're going to unhide the sketch from that original revolve that we made. Now since we're going to use a revolve, we're going to be cutting away, we're going to be removing material from our existing body. We're going to use the revolved cut feature. And we're going to choose the axis of revolution from our original revolve, and that gives us one of our grooves. Now looking at this, I'm starting to realize, well, first let's jump back in here. Let's toss out a dimension here. We want this to be defined. Let's call that 1/4 of an inch. But I'm just looking at this and going, you know what, I think that's longer. Maybe this is shorter than what I had given it. And the proportions of mine are a little bit off. But what's great about SolidWorks is we can always jump back in here. We can tell this is 0.8. Maybe this is only 0.225. And I always misclick. There we go. I think that looks a little closer. I'm sure the dimensions are still off, but gets us a little closer in the ballpark. Which also caused that groove to now be slightly too far away. Let's hop back into that sketch. Change that to 0.3. That puts our groove a little bit better, a little bit closer to what he's got. Now he's got 3 grooves, obviously. We're going to use a linear pattern to duplicate our feature. I already hid this sketch again, which I actually want it. We can use that same center line to define our direction. The arrow is currently pointing the wrong direction. I'll just show you what I mean by that. If I select this, it's going to be duplicating it in the direction of that arrow. Go ahead and reverse that. You know, the stock came up with 0.1 and a duplicate of 3. That looks pretty close. Let's go ahead and keep that. It's close enough for what we're doing, which is just guessing at his dimensions. Yeah, that's looking pretty good. I think he's got some radiuses on here. Go ahead and just throw in a fillet radius. I'm going to take a wild stab here and guess 0.01, 10,000ths. I'm selecting faces. You can select faces, you can select edges. Either one, they work equally well. In this case, I think I'm just going to be slightly better off to select faces, a little bit less selection right now. You know, obviously he's got to put a magnet in here, so probably using some kind of a drilled feature. Well, I know Brad doesn't actually drill. So we'll choose the style, the hole type. We just want a standard drill, which is I think what mine always defaults to, but obviously you can choose a counter bore, which would let you actually set it up. Ooh, that caused a nice hang. Lets you actually pick a screw size, and they have some nice defaults in here. Like I said, we just need a standard drilled hole. We'll go down the list here. We'll choose the size. 1/4 inch I think is exactly what he's using, and 0.28 is going to be pretty close. This has already set it up for a countersink. I always use a default of 120 degrees because that's what I center drill with. So that's my default set in there. It looks like it just broke a little bit of an edge. I like these default settings. We'll keep them. Maybe we'll jump back in here and make some changes. So we switched over to the positions tab, and then which automatically starts creating a sketch. If you weren't just making a single hole, you can make multiple holes at the same time. I'm going to undo that because we just want our one hole. I chose the center, our origin, because that's where we want our hole. Click OK. And we got a hole here. Like I said, I know Brad doesn't actually drill. So let's go in here, go back into that feature. We're going to go show custom sizing because that'll allow us to change our point. We'll change that to 90 degrees to give us a flat bottom. I'm not actually going to program this feature, so it doesn't matter. Just to show that it can be. I just made a newbie mistake. We need to change that to 180 degrees, not 90 degrees. That gives us a nice flat bottom to our hole. We can go ahead and do a cross section to take a look at that. Okay. Nice flat bottom hole. That's, I think, about what his time mag is going to look like. I think that completes it. If anybody has any quick questions or comments, let me hear them. I'll probably just start programming this right when I finish. I'm going to go ahead and save this and get this video uploading. Thanks.